Okay, so I wanted to add to Amir's earlier talk two more food guns, basically. We all like those. These are two cases that we encountered at my workplace over the last few months. And they're interesting since on the face of it, no one did anything wrong. And yet, disaster ensued. So, I gotta tell you, I love const. And I used to love, until this case, to make data members, to make them const. I mean, what's the worst that can happen? The worst case is that you can't move such an object, so it will be ill-formed and you remove those consts. But it turns out that worse things can happen. So in this case, we have class C, a normal class, has some logging on the copy constructor and move constructor. And I have put an instance of it in struct S. Everything is fine. We can see that I am moving an instance of S through the call to function F. And you can see the move constructor being invoked. But as I said, I like doing const. And if anything goes wrong, it will fail to compile, so no problem there. Wait a minute, where are those compilation errors? And what am I seeing down there on the right? It says copy constructor. Whoops. So what's going on here? I am indeed moving S. The default move constructor of S is going to attempt to invoke the move constructor of C. Or rather, it would invoke some constructor of C, which, it will get the C instance with the current value category, which now has a const in it, so it will get a const star value, which of course will not bind to the regular move constructor, and it will happily bind to the copy constructor. Now imagine if C was a huge vector, which you were sure you were moving, so that would be our first, whoops. Takeaways as currently expressed in our coding conventions after this incident. We no longer allow const data members unless the containing class is both non-copyable and non-movable. I like to call that non-transferable. I enforce this rule less on primitives where I don't really care if it's a copy or a move. Second case, this is a nice one. So we had a function that needs to return some OS internal, some string contained in some Windows database. So it's some constant memory address, no reason not to just return a const char pointer from there, no issue. And occasionally, if this function doesn't find that resource, it returns an LPTR. Okay, all fine. Then we needed some additional functionality. We needed, depending on some Boolean switch, to sometimes call a second function which needed to build its returned string dynamically and return a std string. And we put those two in a ternary condition. So what happens now if we still call F1 as before? Yep. So when you put something this way in a ternary condition, you get the common type. The common type of a char pointer in the std string is a std string, and you get the std string constructed from a null pointer, which is undefined behavior. Oh yeah, and as in the first case, no one did anything wrong. So here the takeaway is a bit more delicate. I also had a long reflector thread. More or less my condition was that we can do probably with this. Just don't return a const char pointer unless it can never be null PTR.
Thank you.